All right, happy Tuesday. I'm going to take a few minutes to go over the Desmos notes that you guys went through yesterday and kind of correct any misconceptions I see. So this is one of the Bell's Desmos slides, and I have anonymized everyone, so we don't know who is who, but these are actual students' answers, which is helpful to go through. So on side one, you had to choose which equation you thought the graph represents. So we have almost 50-50 here on choices. And I will say there's not one correct answer as long as you had good explanation to back it up. So if we take a look here at some of the 120 plus 3.7x reasonings, we see the line is starting at 120 and going up slowly. That is true. Here we say that the graph looks linear, and so we know that linear graphs go in the form of y equals mx plus b. I really like that explanation. The graph is increasing, not a lot, but it's going up. That is true. And then we get into choices of our other equation, and this is the answer because it's being raised to the x power. Someone else said similarly, I chose this one because we haven't done any adding. So I do appreciate the fact that we recognize we've been talking about exponential growth. So maybe the answer here should be exponential. So I do appreciate that. It means we are paying attention to what we have been learning. But either answer is fine as long as we have a reasonable explanation. It is hard to tell because we don't have any points here, which leads us to our next question, our next slide. What information might help you decide more easily whether the graph represents linear or exponential function. So here someone tells us the line is going straight, so we can tell it's a function, okay? If it was exponential, there would be a slight curve at the bottom, so maybe we're going back to thinking, is it linear, is it exponential? But again, we're looking for, like this one, the graph should be bigger. So meaning that we need to zoom our lens out and see over time, over the x-axis, is it going to continually be linear, or eventually are we going to see that curved increase that we would see with exponential? So yeah, if we had a bigger window of our graph, we would be able to tell more easily which type of function it is. And I like this answer down here as well. An exponential function is never the same, but a linear function is constant. So that's talking about the increase. So if this was linear, it would stay increasing the same amount each time, whereas if it was exponential, it would start to increase more rapidly as we continued on. So those are some good two responses. Slide 3. How does the investment, so we had this whole thing, hopefully you watched the short video clip, but for bonds, how does the investment grow with simple interest? So it was 2% simple interest. So if I look at the bonds here, it goes from 1,000 to 1,020 to 1,040. So it's increasing by the same amount each time, and more specifically, it's growing by $20 each time. So those of us that said the investment growth grows with simple interest each year grows by 20 would be correct. And that's going to make it linear. Since it's growing by the same amount each year, that represents a linear function. So we want to, again, talk about it's not going up by 1,000. It starts at 1,000. That's how much we're initially putting into the bank, but it's actually going up by $20 each year. $20 is 2% of 1,000. So that's simple interest. It's going to grow linearly. Whereas when we're talking about 2% compound interest, okay, majority of us here chose the multiply by 1.02 because this was multiple choice. So hopefully what we did was take 980 and we did each of these four things to it. And we found that when we multiply by 1.02, we get the 999.60. Which this answer right here is saying perfectly. 980 times 1.02 equals 999.6. Here, this person is doing it after 1 year and after 2 years, except after 1 year should be the 999.6 and after 2 years should be the 1019.59. Okay, so I like all of us that are actually solving to figure it out. Okay, this person chose add 20 because it has $19 more. So it's really, really, really close to adding 20, but we're not exactly adding 20. So this one's not linear. It's going to be exponential and it's exponential growth because we're multiplying by a number that's bigger than 1. All right, slide 5. You need to create an equation y equals mx plus b form. So this top equation is perfect. Y equals 20x because it was increasing by 20 each time, plus 1,000. 1,000 was the starting amount. So some of us were close. We just forgot the x. Remember, we need to have an x in our equation, and the x goes with slope, which is the 20. This one was not exponential. Yeah, so again, we're just missing the x in some of these, but this top one is great. All right, so this time we needed to write an equation for the exponential savings account. So I gave you a hint of what it should look like. So again, this top one, this one is awesome, top 4. Beautiful, 980 is our starting amount. 1.02 was the percent that we were increasing by, and it's raised to the x power. So the only thing I would change in this one is change the 1 to an x, change the 2 to an x. Okay, so very close. Which investment option should the family choose? Majority of us chose savings account, and I'm going to agree with the savings account because even though right now, after 2 years, the bonds has more, if we want to leave it in there for a significant amount of time, our exponential growth is always going to grow faster over time than our linear growth. So if our family wants to leave it in there for 10 years, say, over that time, our exponential growth is going to surpass our linear growth. So I would say savings account. But if you did choose bonds instead because there's more money in there, that is true. After 2 years, if you're only going to leave it in there for 2 years, I would choose bonds as well because we're going to earn more money. So you need to just consider how long you're going to be leaving it in there. As far as our graphs go, pull these up. Just looking at these very quickly, I only see one that's correct, and it's only this first one. So we've got our y equals, this one even has a tiny mistake. So instead of 2x, it should be 20x plus 1,000. So we can see here is where they intersect and where our exponential is going to surpass our linear. So let's say if we leave the money in there for longer than 11 years, we would rather put our money in the savings account than the bonds account because the savings account is in red and our red line is going to surpass our green line. Okay, so yes. But if we leave it in there less than 11 years, we want to choose the bonds because green is going to have more money. Let's just take a look at this one to see what was wrong. Okay, so the only mistake with this one is that the x should be with the 20, not the 1,000, and then we would have it correct. All right, a couple more. This one's really important, so I'm going to go look at the original. So we have this graph here, and I'm going to show you guys this real quick because I think it's important. We need to fill out the table where f of x is equal to 2x and g of x equals 1.01x. I'm going to show you a couple of these. So I'm going to type f of x equals 2x on line 1, and on line 2 I'm going to type f of 1. Then we're going to type f of 10. Then we're going to type f of 50, and I'm getting these numbers here from the x values. Okay, so what's happening is when I input 1 for x, I get an output of 2. When I input 10 for x, I get an output of 20. When I input 50, I get an output of 100. So these are the values that need to be going into our chart, and I'm not going to be able to type those in there. Maybe if I go back to summary, or I can just pull it up. So like this first one, if I can make it bigger, there we go. Okay, they put the appropriate numbers 2, 20, 100, 200,000 in there. It looks like our g of x for these are incorrect. I'll do just a couple of these. So g of x equals 1.01 raised to the x power. So g of 1, g of 10. Okay, so g of 1 is 1.01, g of 10 is 1.1. So this is incorrect. It's not 10.1. So we just need to go through and fix these. But this is how we use Desmos to evaluate a function. This is very important and helpful to know. Struggling. Hold on. Oh, no, it doesn't want to. I think it froze. Oh my gosh. Okay, well, that froze for a second. So hold on. Going to figure out which one's going to grow faster. And again, oh, there we go. Okay, don't know what just happened. Just being slow. We want to figure out which one grows faster and explain your reasoning. So it looks like more of us chose 2x. And let's look at one of these answers. In the graph, it shows that this equation goes upwards farther. The slope of 2x grows faster. So initially, the 2x is the better choice. But remember, what's key about this whole lesson is eventually, over time, the exponential will always grow faster over time. So if you're planning on leaving something in for over a certain number of years, you want to choose the exponential. So if I can tell you guys one thing that I want you to remember, exponentials will eventually always grow faster, okay? So if you need to correct anything from your Desmos notes, do that. I've also posted a video with homework help for the McGraw-Hill practice. Like always, email me with any questions. Have a good Tuesday.